So, Chapter 6 test review for Algebra 2. We're going to start off with the exponential growth and decay and compound interest, okay? I will provide these formulas for you. I'm just not going to tell you which one to use for which problem. You just have to know which one to use, okay?
The rest of the questions will be.
Okay, number 1, it says an employee receives a 3% raise once per year. If the employee's initial salary is $75,200, what will the employee's salary be after 6 years? So what we have to decide, is this exponential growth, is it exponential decay, or is it compound interest? What do we think? Why do you say growth? Right away we can rule out compound interest, right? Because it doesn't say compounded. Okay, so that one's out. Now we just have to decide, is it growth or decay? What gives it away that it's growth? It says raise. Okay, so we are going to use the y equals a times 1 plus r to the t. Okay, so this one is exponential growth. Okay, I'm going to come off to the side here. We're going to label what we're using. So what does A stand for? Initial amount. Yep, what is my initial amount? Yep, 75,200. Our next variable is R. What does R stand for? Where do we normally get that from? We get that from the percentage. What do we have to do with that? Yep, take that, divide that by 100. 3% divided by 100 is 0.03. Okay, and then our next variable is T. T is for time. What is it for this one? 6. Once we have everything, we can go and plug it into our equation there. So this turns into y equals 75,200 times 1 plus 0.03 to the 6th power. Order of operations, what do I have to do from here? Yep, I gotta simplify those parentheses first. If I add 1 and 0.03, those just kind of squish together to get 1.03 to the 6th. This is where we grab our calculator. What do I do next? The exponent. 1.03 to the 6th. What do I do from that? Yes. So I type this in my calculator. What's after that? Times 75,200. What do you got? You should get 89,792.73. Okay. Double check. Do this first to the 6th power and then multiply by this. Okay. For rounding purposes, I'm not going to be picky about this side. Okay. What I will be picky about is this. That should be an exact match. Okay. These numbers should exactly match. That's telling me you're using your calculator correctly. Okay. All right. So this one right here is our answer. Number 2, it says a robot vacuum cleans a dirty floor using multiple passes. During each pass, 18% of the dirt is removed. If the floor initially has 14 ounces of dirt, how much dirt will remain after 9 passes? Are we doing compound interest? No, because it doesn't say compounded, right? So we got to decide, is this exponential growth or is this decay? Yes, what tells us it's decay? It says removed. Yep, so we know that this is decay because of that context clue. Okay, so since it's decay, we're going to use y equals a times 1 minus r to the t. So let's come off to the side, label some things. What's a? 14. Yep, our initial amount. What's r? Yep, we have that 18%. Don't forget to divide that by 100, so we get 0.18. And then last one, t is 9 passes. Yep. So this is where we plug her in. We get y equals 14 times 1 minus 0.18 to the 9th power. Again, what has to happen first here? Yep. So you take 1 minus 0.18. What did you get? 0.82 to the 9th. Okay, order of operations, what do we have to do in our calculator first? Yep, 0.82 to the 9th. And then last, times 14. Yep, you should get 2.35. Number 3 says find the total value of the investment after the given time. $25,100 at 5% compounded monthly for 2 years. What kind of equation is this? Compound interest. Okay, so that equation is going to be that A equals P times 1 plus R over N to the NT. Again, I'm going to come off to the side. What does that P stand for? That's the price, yep, the amount. So we get 25,100. R is, yep, that 5% divided by 100, we get 0.05. And then N is new. Where do we get N from? Yeah, it comes from whatever it's compounded by. So remember, this is yearly. So it says compounded monthly. Well, how many months are in a year? 12. So that's our N value. And then T is time, which is 2 years. What if this, instead of monthly, it said quarterly? It would be 4. Okay, it would be 4. So plug everything into our equation here. We have A equals, bless you, 25,100 times 1 plus 0.05 divided by 12 times 12 times, or to the 12th times 2. Order of operations, what do I do from here? Yep, what part of the parentheses? Yep, that division. So type 0.05 divided by 12. Leave that in your calculator. What do I do next? We're going to do this all in one shot. What do I do after I have this? Add 1. Yep. What do I do after I have this whole thing? Yep, to the, what's 12 times 2? Yep, to the 24th power. And then our last total step after that whole thing is multiply by 25,100. You should get 27,734.03. Again, am I going to care about this side? What do you round it to? No, am I going to care about this? Yes. This right here tells me if you use your calculator correctly. Biggest thing on those equations is just to make sure you go slow when you're doing order of operations. Okay? All right, and last one on this side, number 4. It said, does this function show exponential growth or exponential decay, and how do you know? Decay. Yep, so I agree, it's exponential decay. And then the last part of that is, how do you know? Because it's decreasing, exactly. And that's all I need for that problem. What would exponential growth look like? Going up. It's be going up in that form. Okay. And how do you know this is exponential growth? Because it's going up, it's increasing. Yep. All right. Moving on to 5 and 6. Do you like these questions? Yes. Yes. Okay. So it's asking, what is the base of a common log? 10. What's the base of a natural log? E. Why do you think I put those on there? They're easy, and they will help you throughout the whole thing. Just to be like, oh yeah, I remember that this is this and this is this. Okay? And those are very important to know. So moving on to number 7 here. When it says convert, okay, all we're doing is we are rewriting. Okay, we are rewriting in the other form. Okay, that's what it wants you to do on number 7. We're not solving. All we're doing is we are rewriting. Okay, so if we're in log form, we're going to go into exponential form. If we're in exponential form, we're going to go into log form. Okay, what method are we going to use this whole time? Circle. Circle, yep. Where do we always start? The base, yep. What's the base here if nothing's there? 10. So we start at the base. So our base is 10. 10 to the 3rd, yep, we circle. Equals 1,000. How can I check to make sure that's right? Right, I can figure out, is 10 to the 3rd actually 1,000? Yes, so you did it correctly. Okay. What about letter B? Where do I start? The base, right? So base 5. 5 to the 2nd equals 25. And is that true? Yes, 5 squared does equal 25. Okay. What about C? Right, it's base E. Good. Do we still use circle method? We still can. Yep, so start at your base, which is E. E to the -1 equals 0.368. And on these ones, do I have to solve anything? No, all you're doing is you're rewriting. Okay, and then D, what do you notice about this form? We're in exponential form now, we got to go backwards. So ask yourself, is this common log or is this natural log? It's the common log, right? How do you know it's not natural log? There's no E. Yep. So we know it's going to be common log, so we need log, what's my base? Log base 8. Make sure that's a little number below there. Log base 8 of, yep, keep circling, 512 equals 3. Okay, finally on E. Common log or natural log? Okay, natural log, what's my base? Careful. E is my base. Do I need to put the E there though? No, I think that's why some of you were saying 3. So natural log of 3 equals 1.099. Oh, it's okay if you have either. There we go. Number 8, okay? It wants us to evaluate. What does it mean by evaluate? Right, we're going to end up solving. So I want a specific number for my answer, okay? So we want to figure out what is log base 4 of 256, or what is this value? How do I figure this out? We're going to rewrite and we're going to do division of common logs. So what this is going to turn into is log of what? Log of 256 divided by log of 4. Does the order of these two matter? Yes. Yep, base goes on the bottom. If you type that in your calculator, make sure you are closing parentheses. So log 256 divided by log of 4, what do you got? It is 4. What do you notice about 8b? It's in a different form, right? Would it be really helpful if we wrote it in this form? Yeah, right? So is this common log or natural log? Common log. So I do log base 6 of 53 equals x. Now, does that look very similar to what we had from before? Yes. How do I solve this then? Same way, right? What goes on the top? Log 53 divided by log 6. You should get 2.22. Yep. All right. 9 and 10. Okay, on number 9, we are expanding. Okay, number 10, we are condensing. Focus on number 9 first. What does expand mean? We're making it longer. Okay, so we're going to expand that logarithm. So instead of having one log, we're going to have multiple. Okay, so what is each term going to have with it? It's going to have that log 8. So let's start with log 8. What is my first term inside these parentheses? X squared. So log base 8 of x squared. Leave it like that for now. Okay. What's happening between the x squared and the y?
They're
Multiplying. What's that turn into? Addition. What needs to go in front of each term? Log 8. Yep, so we have log base 8 of our second term y. What's happening now between our third term? Division turns into? Subtraction. How do I write that last term? Log 8 of 3. Can I leave my answer like this? There's one thing I gotta fix. Yep. Remember our exponents? What do? They go to the front. Yep. So this turns into 2 log base 8 of x plus, do I do anything with others? Nope, those can stay. Minus log 8 of 3. Okay. Now number 10, we're condensing. What does condense mean? making it smaller, okay? What do all three of those terms have in common? All log 2, so that's what we bring out in front. Log 2, start your parentheses here. What is my first term? 3. What's happening between my first and second term? It's addition, so it's going to turn into multiplication. So our first term's 3. What's my second term? X to the 4th. Yep, remember that number in the front becomes our exponent. Now what's happening?
Division.
Yep, subtraction, so it turns into division. And then what's my last term? 7. Do I need to do anything else? Nope, done. So biggest thing when condensing, don't forget those numbers in front. They become that exponent. Okay, number 11. On number 11, A through E, it just wants us to solve the logarithmic expressions and the exponential equations. Okay. So, what do you notice about A? Bases are the same. We have 15 and 15. What do we do when they're the same? We can cancel them out. The reason we can do that is because if the bases are the same, do you agree their exponents have to be the same? Okay, in an equation. So these cancel. So we're left with 2x plus 2 equals 8x. What do I do from here? Yep, subtract that 2x. So we have 2 equals 6x. What do I do from here? Yes, divide by 6. Careful. A lot of you are going to go x equals 3. But it's 2 divided by 6. What does that turn into? Right, I don't want decimals. Let's leave this one as a fraction. What can I reduce 2 over 6 to? 1/3. Yep. Okay. How is B pretty similar? They have the same bases, right? They are both logs, but biggest thing we want to see if these are the same. If they are, what do? Those can cancel just like the exponents could. So we're left with 7x plus 5 equals 5x minus 9. A lot of different ways you can do this, but someone help me. What should I do here? I heard add 9. I'm going to add 9 here. So we have 7x plus 14 equals 5x. Subtract 7x. So we have 14 equals negative 2x. Divide by negative 2. Yep. So what's 14 divided by negative 2? Negative 7. What do you notice about C here?
Can we use circle?
We are going to do circle. One thing I want you to notice first, though, we have log base 4 over here, but do we have that over here? Right, there's only one common thing one thing that we look for that they have. Okay, only one side has that base. So, what do we do since we don't have that? We can't throw it in there. What we do is we're going to rewrite this into the other form. So we're going to go into exponential form to help us out. What's my base? 4. So I start with 4. 4 to the... Yep. So 4 to the 3rd equals 5x plus 9. How did that help us? What'd you say? Took the log out. How else did that make it easier? Because now can I figure out what this is? Yeah, what's 4 to the 3rd? 64. So we have 64 equals 5x plus 9. Now it's algebra. What do I do from here? Subtract 9. So we have 55 equals 5x. Divide by 5. X equals 11. Looking at D, what do you notice here?
They're not the same.
Bases are not the same. So 8 and 16 are not the same. What you check, can I turn 16 into base 8? Okay. What a lot of you are going to say is yes, but you cannot. Okay, because a lot of you are going to be like, well, I can do 8 squared. But why can I do that? Because it means 8 times 8. It does not mean 8 times 2. So I cannot turn 16 into base 8. So what do we do if we can't turn one into the other?
Change them both.
Try to change them both. So we're going to go down from 8. Let's check 4. Can I write 8 with base 4? How?
Times 2.
So remember, we have to change them as exponents. Can I do that? No, because that means 4 times 4. That does not give us 8. So we're going to go down one more. What's another one we can try? Base 2. How do I turn 8 into base 2? 2 to the what power? 2 to the third power. What do I still have there? X. Okay, equals, what can I turn 16 into base 2? 2 to the fourth, and I still have that x plus 2. Okay, so what do we do to clean this up a little bit?
Distribute.
Yep, distribute here. So this turns into 2 to the 3x. Over here, treat this as a quantity. This turns into 2 to the 4x plus 8. Right, now the bases are the same, so I can cancel them out, and we're back to what we looked like on part A. Okay, so this turns into 3x equals 4x plus 8. What can I do from here? Yep, subtract 4x. So we have negative x equals 8. Last step. Yep, divide by negative 1. We have x equals negative 8. What do you notice about part E?
They don't match up.
The bases don't match again, okay? Do you agree our bases are 4 and 9? Okay, because why is 9 still a base? What's technically here? A 1, right? So that is still a base. Can I turn 9 into base 4?
Yeah, no.
There's no way I can do that. Okay, can I change both of them into a base 2? No, can't do that either. What do we do if we can't do either of those things? We bring that in our common log. So what we're going to do is we are going to log both sides. There we go. So what we have is log 4 of x minus 3 equals log 9. What do I do to clean this up a little bit? Yep, bring down that exponent. Treat it as parentheses. So we have x minus 3 log 4 equals log 9. What do I do from this point? Distribute that log 4. What I'm going to ask, is this going to turn into 4x? No. Okay, that number or variable just goes in front. So this turns into x log 4 minus 3 log 4 equals, did I do anything with log 9? No. Okay, now again, our whole goal is to get x by itself, right? What do I do next? Good. Add 3 log 4. When I do that, can I combine these two as one term? No. So this turns into x log 4 equals, does it matter the order I put these in? No, I'm just going to go log 9 plus 3 log 4. And then what's our last step to get x by itself? Yes, divide by log 4. So we have x equals, you do not have to rewrite this step, I'm just going to for purposes. So we have log 9 plus 3 log 4 divided by log 4. What do we do from here? Calculator. What do you have to be careful with in your calculator? Parentheses. So remember, every time you open log, you got to close the parentheses afterwards. Okay, and then there's one more thing I have to make sure to do. Make sure you put the whole top part in parentheses also. Okay. So if you type that into your calculator, you should get x equals 4.58.